Welcome to UR Tech Partner, your ultimate destination for mastering AI and DevOps. Dive into the world of cutting-edge technology with us and unlock the secrets of artificial intelligence and development operations. Stay ahead of the curve and elevate your tech skills. Learn AI and DevOps with us today.
Okie dokie, we have seen how to create Docker, right? We have done this, then checking running Docker, we have checked this too, Docker state, we have also seen this, checking the image, Docker images, we have stop and restart the Docker. So we have discussed in the previous video what is what, and there are two major categories: operating system based Docker and application Docker. This is nothing but you just get the base image like Ubuntu, and then on top layer you add another application or any software, and it automatically become application based Docker. There is no much difference in it, but if you just need only bare, for example, Windows, Ubuntu or CentOS or whatever, then actually it is operating based Docker, which means that there is no application running on top. But if you get like Nginx, you pull this Nginx from the Docker Hub repository, then it's application Docker because it has base image system, plus on top it has application running. It become automatically application engine, which is great. How yes, we have also seen in Docker stats that how it's create process ID attached to it. Even in the Docker PS, we have seen this. For example, here you can see that if any Docker was running, then you always Docker stats. There is nothing right now. So there is no process ID running right now, but if it is, then it's coming here. And that's how you check it from the Docker stats. We have also seen this. And if there is no process ID, then it means that it automatically kill the container. This is another concept, very important, that if no process ID for any Docker is running, it get killed automatically. So when you stop any Docker, it destroy itself, and it's not when you terminate or remove any Docker, it's not stop. You can recover, but if you terminate or remove the Docker, it is not recoverable and it's forever lost. There are two different ways to get Docker: the interactive mode and detach mode. Mostly we need detach mode because we don't want to get into the Docker and do something customized. Rather, we just want to run it in the background. And if you want to run it in background, then you use that. And if you interact with Docker or test and trial something, then you use this one. We have also used both of them. Right now, if you use IT mode, then you must need to specify the command. You must specify that then you must specify the command or process like shell, which is bash in our case. Normally we use always bash or any shell, so that which interaction command you want to run. Yeah, you must create Docker using IT mode if want to create a user and PID. So, well, if you are not running any application Docker, then you need to create the process ID, and to create the process ID, you need to always run it as an interactive. When you do that and it's create, I can maybe show you this example live. This is not that, that's that. For example, what I can do using Docker images, I have some images, And now I have this is the operating system based Docker, because it has the Ubuntu machine. And what I can do is Docker run, and maybe in detach mode, or maybe even if I not run detached mode, because it is operating system based Docker, and then I can uh, Docker run, and I can say that nothing is get copied from the Ubuntu paste. And if I now run Docker PS, you can say that I cannot see anything. Technically, if I create a Docker, it should have, or it must be showing here in this column. If I want to see it now, I can run Docker PSA, and it's gonna see me every Docker that is exited and not worked. And here, as you can see that these are the Docker actually, which are kind of, not running. So Docker run name Ubuntu OS based Docker. Either I need image ID or I need that. Name OS based Docker. Docker RM um Docker RM this. Docker RM okay. These are some tasks you can do. You can remove the Docker whenever you want, and you can add the Docker in the detached mode as well. And we were discussing that if you create operating based system Docker, then it's never create a user PID, right? Because it get killed automatically. Even if you create it, it's get killed. You create it, you run it, it get killed. I can also show you str the Docker start, and maybe this is also operating based Docker, which means that it gets started, but Docker PS is going to show me nothing. And if I run Docker PSA like all, then it says that 9 seconds ago this was. Yeah, you can use double dash name to name any container. So yeah, that's the things you always need to do for now. And what else you need to do? As you, okay, how we can do this? So next question arises that if I want to create a PID so that my Docker won't kill. In future video, I will explain that this is actually not an industry practice that you create a Docker from the customize or this way. Normally, you create a Docker file, which is actually a sense of using Docker. You always create a custom image with Docker file. You build Docker using Docker file, and that's how you interact with Docker. Normally, you don't interact Docker in this way, but this is just for the understanding purpose. But in the industry, it's not being used nowadays. Now let's create a PID. So for creating the PID, what I need to do is that I should run Docker in interactive mode. For example, if I run Docker execit and exec execute it interactive container is this here. Okay, why on earth it's not get copied anything? And if I run it, then I always need to tell that okay, this Docker has been already exited, which means that this Docker is stopped already, which means if you want to create a Docker, we should do Docker image and if you now create another Docker run and Docker run it and then you do this and bash. Now you are in interactive mode already, and if I'm in interactive mode, I'm inside Docker, I can maybe say lsb release and a doesn't work, I don't know, echo etc lsb release. That should get, and there's that shows us that this is 24 Ubuntu and nothing else, and this is Ubuntu Mobile, which is great. Now I use Control PQ, which is normal way to getting out of Docker. Now I'm out of Docker. Now if I run Docker PS, and for sure it's now giving us that this Docker, which has been created using the interactive mode, and now it also attached one process ID to it, as you see now. So that's how it is important actually that you must create a process ID for the operating system based Docker. If your Docker is already coming from any application side, for example, Java server, Python installed already, Nginx, Tomcat, any kind of web server or any server already configured, and you pull it from the Docker Hub, then it's automatically configured in the way or created in the way that it has some background processes. And when it has background processes, it means that it has already a process ID and it doesn't kill automatically. And that is actually difference between Docker exit and Docker PQ. that if you use exit command, then it's kill the process ID, which means that Docker don't run in the background and it's kind of lost. And yeah, so yeah, this is the concept pretty much for the Docker basics. And it is always industry practice that if you have to now remember that, okay, was it application Docker or was it OS based Docker? And if it is, the next thing is that for application based Docker, exit or PQ method has no difference because it has background processes already. It has background processes already. You can use any method. For OS based container, if you exit Docker using exit command, the process has gone in Docker automatically close or terminated. And any application, if it is running on that, it's also exit. Now, very important and last concept for this basic topic. Okay, we have already seen this much. What is the difference in all kind of different Docker modes, operating system based Docker and other Docker? The only concept which is now necessary is the port mapping right now, which is kind of very important. So we need port mapping normally when we need to interact or we have to work with the traffic from and within the Docker. We need incoming and outgoing traffic from the container. One thing which is very important, let me draw concept of port mapping in Docker. Okay. So if I do that, then the thing is that, for example, this is Docker. So for example, there are no more shapes. It's very sad. Doesn't have much shapes here. There should be many different shapes. Sad. Okay, for example, this is now Docker. And inside Docker, we have this is virtual machine. And inside virtual machine, we have Docker running, right? So now we have that much information given. So this is VM on the top, and this is Docker, right? This is act like a computer as well, and that virtual machine is also a virtual machine that has different port. Now, for example, here is port, and Docker has some ports here and here. Now, for example, this port can be range from 0 to 100K. Similar here. And we need to expose one port. For example, very common, we need to expose the port of Docker, which is port number 80 or port number 8080. Normally we need these ports. Or any port like 22 or any single port from 0 to 100. We need that, right? And now if we try to install a container from the Nginx, then we need to expose a port number, and we need to map these ports together in a way that the traffic could go in and out from both direction. So for example, I open the port 1000 here, and here the port is 80, and I map that port in a way that I say that, okay, Docker run detach mode, or maybe interactive mode, whatever, and then I say p when I say small p, so small p and big P. Small p means that manual manual mapping, and this means that automatic random port mapping. Automatically random port mapping. So this is two concept here. So if I here say that small p, then I have to give the host port colon Docker's port, right? And then here I can give the image, whatever image I want to use here. So for example, and then if I see now Docker PS, it's gonna tell me that which port is mapped to where, and we can also then get the IP to run in the browser. In browser, VM IP, VM public IP, we need that. We need to get the public IP address, and then the port number of VM map port VM. What is mean by map port? For example, this port here, which is at the outer shell here, this port, these port, for example, 0 to 100K, 10,000, whatever, and it is automatically mapped to the internal container. And container could be many different container here, and your this port make it differentiate that which traffic goes from which. So practically, if I, for example, say that Docker pull Nginx, for example, I say Docker run d and dash small p, and then I say, for example, 500. I don't know if this is 72,000 mapped to the port 80 here custom, and the image name is Nginx. And there is again typo here. Now here we need to see that available port. I don't know. Maybe I can say 1000. Should work actually. port number 1000. Okay, it hasn't found anything here. Some ports are actually occupied or not available. Then you need to actually see or have an idea of that. Now if I run docker ps, now keep in mind that I don't have mentioned now interactive process. Even then I didn't mention any interactive process. I have written, if you see here, D. D means that detach mode or in background. But even then, if I run docker ps, which is docker processes, it's showing me this docker is running. Why? Because it has entry point command by the nginx, which is running in the background, which prevent it to get stopped. That's why it doesn't terminate it and run in the background, which means that any application of the nginx which is running on here is always accessible. Now to access it, we need to run, for example, what we need to run, we can see that IPA somehow, and I don't know, the public IP look like this one here. The Docker IP is right here, which is not accessible always. We have this IP, and now maybe what we can do is that we can write port 1000 on the browser. Let's do that. Localhost and port 80. No, not port 80, but port 1000 we have mentioned because that is the port which is mapped. Great. Port 1000 was the map to the port 80 of the container. And now if I show you the concept here, which is kind of this one, and the similar concept here, actually, what we can do is that we can see similar concept here, which is actually kind of this one. This is port number 1000, which we map to the port 80 here. And this is virtual machine over virtual machine. And the IP of virtual machine is this one here, right? And maybe if I can do it a little better. This is the IP of this machine here. And when we run IP address like localhost and then port 80 in the browser, not port 80, because one thing which is very, very important, make sure that none of the traffic of the port and the IP address is never accessible from the outside world. If you want to interact with the container, you always need port mapping or the port forwarding. Both of the concept here, port number 1000, which is VM, is mapped to the inside, and whatever I write here on 1000, this port is give here a request. When I write 1000 here, it enter, it gives a request to the container port 80, and then port 80 knows that you have been mapped on this IP, and it sends you this response back. So yeah, that is pretty much about port mapping. This is very important concept. Then what is next in our agenda for today? There are a lot of things which are very important here. So today's agenda actually here is that, or maybe if I can docker initial command and I can show you docker Oops. Docker file and Docker file and some advanced concept like uh, Docker repository, custom images. Today we are going to discuss what is Docker custom images, why we need them, how to create Docker Hub account and push your custom images so that it is accessible from publicly. Then our agenda today's Docker commit, Docker file, Docker declaratives, or syntax, and Docker concept of Docker build. Some other concepts are down the line, for example, okay, Docker file, Docker build. Docker build is used to create your custom images and something like that. Yeah, that's the agenda for today. And this is very important step. Very important. Where does Docker fits in dev stack? Why we need actually Docker? So DevOps is a complete piece of puzzle, right? And where exactly we need Docker in this technology stack of the software life cycle, software development life cycle, where actually we need kind of where exactly we need to need that. Great. So let's prepare it. Let's let's create some custom image file first. Let's create a Docker account first and some naming convention and see that how that works. Yeah, these are the concept, in fact, which we are really going to use here. And yeah, this is pretty much a very standard approach. This approach is, kind of manual approach, just mostly used for test and trial purposes. And this is widely used in the industry, which means that you create your complete text file, Docker file, and you run that Docker file. Sometimes you have seen in the repositories that it's like that. Yeah, this is pretty much it. Let's now do that by first. Okie dokie, let's do first by first a manual approach. Manual approach means that I just go here. I have different Dockers running right now. This Docker is based on Nginx, right? And this Docker is based on Docker ID, this Docker image ID. And if I go to Docker images and if I match this one with this one 35, this one and this one, it means that it is running on Ubuntu. To make it alive, we have created interactive process, and then we come out of the Docker using Docker PQ, and this Docker is actually right now running smoothly. Now, for example, we need to create a custom image. So what we can do is that based on the Ubuntu images here, I can get into this Docker. Docker execute interactive. Docker ID should be this one. Docker ID should be this one, and mod is that one. So this is now Ubuntu base raw Docker. Now I want to install in it some Nginx manually. So inside it, what I can do, I can run some commands, which is like, for example, if I go here and if I go here, I minimize this thing, might be, or da da da, like that. And now I go and first, for example, I install Nginx in it. This is what I'm doing to make it custom. Okay, now Nginx is not available in this container. What other example I can give here? In this container, why Nginx is not? It should actually connect to the Ubuntu. Networking is there. Well, package list and some restricted, non-restricted has been done. And now it's installing something. For example, in this container, we need specifically this Nginx setup, right? And then actually, this is the container. From this container, we want to create something. So we can make any kind of change. For example, let's, okay, let us then get install. Okay, so let's quickly do something here. We are updating the Vim. Let's so this is a normal step you always have to do. This is normally a setup you have to do. So A B C D D D D. One. Okay. So it has done something for us. Now what I can do here is that I can make another directory, which is essentially going to create a configuration file. I pull some, I create another file here and create my standard credentials here. Okay, in configuration dbprop. And then what I can do is that I can change that to that. Insert mode. WQ. And for example, now we have created something. So it is not necessary what you do here. You can create any kind of configuration, whatever you want, whatever you need, XYZ. So pretty much anything, right? You can do pretty much anything here. Aha. So that means that that was not right. Okay, that was that. Q, I don't know. And yeah, for example, we have changes some stuff here. We have installed Nginx and we have done some other stuff. We have create a configuration file and everything should be good. And we have changed some other file. Maybe we install dependencies. We need to change some other stuff. Whatever you can possibly do in any window, you can do it. And then you safely come out of the Docker. PQ. Escape sequence now. So now here the command which creates image from Docker, whichever Docker you were running right now, you were running this Docker right now, this one here. You have made some changes in this Docker, a manual Docker, Lucid Query, and now you need to write a command in the syntax, which is this one. So this command always you need to make, this is always vary and it is standard, and you should actually have that, new image name. Okay, to create a custom now image, we have made a lot of changes. Here we have made some changes in this name, this container. Now we want to create a custom image from these changes. So we normally exit from the Docker container. It is running right now. It is not exited or destroyed, which is good. Now we can create another image. And the command for that is this one. Command is this one. Docker commit create new images, and this is the ID, container ID from which I want to create. This command is always standard process. Don't worry about that. You can get it from Google. This is same for any kind of server. If you're running Nginx is gonna provide you this Docker command to make the Docker alive as a process in the background. If it is Python server, Python. If it is JavaScript based React server, then it is React. So these command may be different, but this command you should write because it make that images or it write custom images into the command, which subsequently you can create a new Docker from it, from for example anywhere. And this is needed to make the container alive. This is the port number where it listen to this Docker image, and this is my custom image is the image. And when I press enter, it create another Docker file, Docker images, and there you go. As you can see here that it has created none because I already had created one. So yes, I can remove Docker RMI, and I can give this as a this, and it's gonna remove this Docker images. And now this is my Docker image. This is my custom Docker image. I can create anytime a new Docker out of it with my my custom image Docker, my Docker custom image from it. So that's how you create a Docker images file from the a manual approach. This is very easy. The steps are here. Again, what are the steps? The steps are very simple. The step is that you can use any base image as I have shown you here. You use Ubuntu, CentOS, Red Hat, whatever you need. You try to make changes. These changes come from your organization, from your setup, what you want to achieve with this Docker. If you want to install Python, Django, and then fast API and create a small application in the Python and you deploy it, then the requirements are going to different. For example, you first create a Python 3, you write your code, then you create a Flask model of the application or a Django model of the application, then you run on database, and ultimately there must be one server that's running to it, and you do a whole lot of different changes. You expose any port where the Django server is written. For example, it could be 8080, 8090 or whatever it is, and ultimately you then, when you're finished with the container, you just hit then CT or LPQ, standard process to exit from container, and then you use this command very similar to the git command, and here you give then message why you need, then you give -c, and here in the commas you write cmd to make my container alive, and then tag name, and then you hit, and then it's creating a new images. This image normally you need at the organizational level. For example, how you want to make it available on the GitHub on the Docker Hub server, similar to GitHub server. If you write a code, you want to make it available to your team, and what you do git commit, and then this code is available to your rest of your team. They can clone it, they can further work on it, and similarly you can do it to push this Docker image to Docker Hub. And first you need to create that Docker Hub account, and then you verify locally that credentials. You again give the password to initialize it, and then you really can push this image with the name and the credential, and the convention to do it to Docker pull your GitHub username. The convention to push it on Docker Hub, you need to my username, my username slash image and version X, right? So that's how you push it normally. And your Docker image name should be in this convention. And when your Docker image name is in this convention, so first you should rename using Docker tag to format of Docker Hub, which is this one. You always need Docker image in this format, and when you push it with Docker push, and it's pushed to your username and accessible to the public. If you want to make it private, then you need to pay for it to the Docker Hub. So the step for the pushing, both of the step for the pushing, like how to push Docker image to repository. The process is same for both manual and automatic approach, right? The method is quite similar for both of this. So next we'll see how we push a certain image, which is custom image, and if it is not renamed, how we rename it into the format what Docker Hub sees. And yeah, that's pretty much it as a next step. And then we'll really see how you create a Docker files. You build a Docker image from it, and then again you can pull them if you want to the repository. So the main important, there are two important steps here when it comes to, so in the declarative actually CMD and entry point, CMD and entry point. These two modules of the Docker's declaratives are very important because entry point is together. You can always make the container live in both of the cases, but in the case of entry point, it is prohibit to overwrite thus to go to IT mode. You cannot go to the interactive mode when you declare your background process with this. You can change process, go to interactive mode. So in this case, you can do this easily, right? That's how that works. And yeah, I guess it is enough for today. In tomorrow's short tutorial, we'll see automatic and approach, which is adopted by the industry standard. We'll create a Docker account and we'll push the image which we have created today. Here, this image, we are going to push this image to the Docker Hub and we're going to create a Docker file. We will understand it and we'll make it more intuitive, and we'll use for that Docker Nginx with port mapping, and we'll see how to deploy a sample app, Java-based sample app, and finally we'll see that how that piece of puzzle fits to how Docker fits to yeah. That's all for today. Thank you very much. Hit like and subscribe button if you think that it has added some value to your concept. Thank you very much. Bye.